Hello everyone. Today we will be beginning our discussion of financial mathematics with an overview of percentages. Now, percentages we can kind of think of as a convenient way of expressing fractions and decimals, basically by expressing them in terms of parts of 100. So when we have a percentage, say 50%, what that really means is 50 out of 100. Or 22.5%, that would be 22.5 parts out of 100, or 225 out of 1,000 if you wanted to write that as a more correct fraction. These are all basically any fraction or decimal really we can express as a percentage. It's just that depending on what we're working with, sometimes one may be more convenient to work with than the other. In the world of financial mathematics, we use percentages a lot, so they'll be very important to understand for the next few videos. So I have an example up here of a few fractions, decimals, and percentages. And what we're going to do is basically we're just going to take all of these and express them as all three: fraction, decimal, and percentage. So the first one, we have a fraction, 4/9. So if we want to express this as a decimal, then all we're really going to do is we're just going to take 4 and divide it by 9, which as it works out is 0.444 and so forth and so on, or we would write this as 0.4 repeating. Now, once we have this in decimal form, when we convert this to a percentage, all we have to do is take our decimal point and move it 2 places over. So in this case, when we're doing this, it's always going to be 2 places over to the right that we move it. So in this case, 0.444 and so forth and so on. If we move our decimal point over 2 to the right, that's going to put it right here. So our percentage is going to be 44.4 repeating percent. So effectively, that means that 4/9 equates to 44.4 repeating parts out of 100, basically. All right. Typically, going from a fraction to a percentage, you're going to want to go through the decimal as sort of an intermediate in between, because it's a little bit easier to go directly from a decimal to a percentage than it is to go from a fraction to a percentage. Because going from a decimal to a percentage, all you have to do is move that decimal point over 2 places. All right, our next example, we have a decimal, 0.37. Now, let's start by expressing this as a percentage. So we're going to do the same thing that we just did. We're going to move our decimal point over 2 places to the right. So we go 1, 2. That puts it right here after the 7. So that would put us at 37%. Now, if we want to express this as a fraction, we can actually use the fact that percentages or decimals, both of these you can kind of get, from both of these you can kind of get the same information. It's probably easiest to visualize going from a percent. So by definition, a percent is however many parts out of 100. So in this case, 37%. If we write this as a fraction, that would actually be 37 over 100. So this is one way that we can do this. The other way that you can do this is by looking at the decimal itself. So we could say this represents tenths, hundredths, thousandths, 10,000ths, and so forth and so on. So basically you're doing the same thing. If you go from this decimal to 37 over 100, basically you're saying that this is out to the 100ths place. You have 37 of those, therefore 37 out of 100 is our fraction. All right, last example that we'll look at, we have a percentage, 55%. So if we want to go from a percentage to a decimal, we're going to do the opposite basically of what we did to go from a decimal to a percentage. So we're going to take our decimal point. There's no actual written decimal point, but we can effectively, there's one here after the 5. because you could also say this is 55.0%, right? This would be the same thing. And we're gonna move our decimal point over 2 places to the left instead of to the right. So if we do that, we move 1, 2, that puts it right here in front of the 5, or the first 5, I should say. So our decimal is gonna be 0.55. To get a fraction, we can do the same thing that we just did a minute ago. So 55% is 55 out of 100. So 55 over 100 would be our fraction. And as it turns out, we can actually simplify this further by dividing both the numerator and denominator by 5. And what this is going to give us is 11 over 20. All right. Now, when we're dealing with percentages, there's a few different things that we'll run into when we're trying to apply a percentage to another number, basically. So one of these is if we want to find p% of b. So say we want to find what is 25% of 1,247. We simply would just do p times b in this case. So lowercase p is basically just this uppercase p percent expressed as a decimal. So for 25%, for instance, this lowercase p would be 0.25, and then we're going to multiply that by b, whatever it is that we're taking the percentage of. The other scenario that we'll see is we want to find a p% change from b. So this can be either a percent increase or a percent decrease. So the formula that we use for this looks like this. So f, that's our final amount, is 1 plus p, lowercase p, so percentage written as a decimal, times b. Now, one thing about this is that because we can be dealing with either a percentage increase or a percentage decrease, this lowercase p can be either positive or negative, actually. So if it's positive, that means we have a percent increase. If it's negative, that means we have a percent decrease. These two down here, b equals f over 1 plus p, and p equals f over b minus 1, or f minus b over b. These are all different ways of basically just expressing this same formula. So let's go ahead and look at a couple of examples of how we can apply these formulas. So the first one, what is 71% of the cost of a $38 item? So in this case, what we are wanting to find 71% of a number. This would be like b from our formulas over here. So in this case, we're trying to find p% of b, so we would use this first one, p times b. So 71%, if we express this as a decimal, that's going to be 0.71, and we're going to multiply this by b, our cost, $38. So 0.71 times 38, what this works out to be is $26.98. All right, second example. How much does a $115 item cost after adding a 6.5% sales tax? So this time, we can think of our 6.5% sales tax as a 6.5% increase of the price of the item. So in this case, we're going to use this formula right here, f equals 1 plus p times b. So f equals 1 plus p, b. In this case, b is going to be our $115. And then p is going to be our percentage sales tax expressed as a decimal. So since this is a percent increase, it's going to be positive 6.5% change. So we would write this 1 plus 0.065. So 0.065, this is 6.5% expressed as a decimal. Note if we move this decimal over 2 places to the right, we get 6.5 back. So that's how we can sort of check that. So 1 plus 0.065 times $115. And this works out to 122.48. So actually, if you put this into your calculator, what you get is 122.475, but unless we are dealing with prices in terms of half a penny, we're gonna always round this to the nearest cent. So 122.48 is what we would actually use. Last one, if a 20% discount is applied, keeping the same tax rate, what's our final price? So in this case, we have a percent decrease. So you can think of this 20% discount as a 20% decrease in the price from what we just calculated, basically. So F in this case is going to be 1 minus 0.2. 0.2 would be 20% expressed as a decimal, and minus because it's a percent decrease, times our 122.48 that we just calculated. And what this is going to give us is 97.98. So one thing to note about this last problem is that if we had done this 20% discount to our original 115 and then applied the 6.5% sales tax, we would have actually ended up with the same answer. And the reason for that is that multiplication is commutative. So if we did $115 times 1.065 times 0.8, that's the same as if we did $115 times 0.8 times 1.065. Now with percentages, there's a couple ways that sometimes you'll see percentages used in kind of a misleading way. So one example of this is basically when we are combining percentages. So for instance, if we have a 25% increase in the value of a stock share one day followed by a 20% decrease the next day, you actually end up with a break even instead of having a 5% increase. So you can't just do 25% minus 20% and say, okay, we have a 5% increase. So the reason for this is that, say our original value is $100. If we multiply this by 1.25, that would be a 25% increase. We get $125. But then, if we multiply that $125 by 0.8, that would be a 20% decrease. Then what we end up is back to $100. So we break even. Another way that you'll see percentages used misleadingly is sort of with discount baselines. So some people might say, oh, if your final cost is $50 for an item that was originally $100, the difference between $100 and $50 is $50, which is the same as your new price. So it's 100% discount, right? Well, no, that's not really true. 100% discount would mean they're giving you the item for free. Discount baseline, or discount should always be calculated relative to the original price, not the new price. The last way that you'll see percentages used kind of misleadingly is when you are adding percentages. So say that you have some sort of expense that is taking up 4% of your paycheck, and let's say that you have that increases to 5%. Well, the amount that you're actually paying when you go from 4% to 5% is actually going to be 1.25. You're actually going to be paying 1.25 times more than what you were paying. So 5% divided by 4% is going to be 1.25. So you're paying 25% more for whatever that expense is, not 1% more. So you can't just do 5% minus 4%, in other words. So these are some things to be aware of when you're dealing with percentages. Thank you for watching, and as always, I'm happy to help with whatever questions you have.